Let's begin with the algebraic method to question 2. We know the total garden is 1,000 feet squared. So the first thing we're going to do is we're going to give our students the opportunity to have a concrete example. However you wish to do this, before or after the assignment, however you want to integrate this into your lesson, if you want to spend a full lesson on this, totally fine, totally up to you. You have absolute freedom. But let's talk about beginning with a concrete example first. So from the picture, we can see that we have two squares and two semicircles, and we unite the two semicircles to become one full circle. So a concrete example would be this. We can say that 1,000, an area of 1,000 feet squared, is equal to the area of the two squares plus the area of the one circle. There's your concrete illustration. Most students are going to get that. So now the question is, well, let's focus on the squares individually, and let's focus on the circle individually. Now hopefully they've got some geometry connections that they can make. The area of the square, well, let's go ahead and let x represent the side length of the square. But they can also use the variable name side length, just as they did from the laboratory. But x is easier in this case. So we'll say x and x. So the area of one square is x times x, which is x squared. The area of a circle is that irrational number, that constant called pi, times the radius squared. So the next equation is now less concrete. This is now more abstract. So what we want to do is we want to tie in the concrete to the abstract. How many squares do we have? We have two squares. What is the expression that represents one square area? It's x squared. So we replace the picture of the square times 2 with 2x squared, since 2x squared represents that. We replace the picture of one circle with the representation of pi r squared, and now we can begin to discuss all the things that they might have been learning in their mathematics classes. So if you're not their primary mathematics teacher, their primary mathematics teacher is now going to thank you because you're taking concepts that they are learning in those classes and you're connecting. You're making connections now. So now we have an algebraic expression. You can ask the question, what does 2x squared plus pi r squared mean? Prepare for crickets because most classes are unfortunately programmed to wait for someone else to answer. And that's what we want to overcome. What does 1,000 mean? So ask them the question, what does 1,000 mean? And hopefully at this point someone somewhere says, well, that's the area of the garden, right? Well, what does 2x squared plus pi r squared mean? Hopefully they're beginning to make the connection. Well, that's 1,000. That's the area of the garden. Well, what does the equation, the equal sign, mean? Well, that means that the area of the garden is the same as 2x squared plus pi r squared. You see what we're doing? We're asking thinking questions. You don't want to say, when they say something wrong, instead of saying, well, no, that's not it, try saying, is that right? What do you think? Does somebody else think something that's right? What do you think? Get them to question among themselves. Say, discuss with a neighbor for 30 seconds. Let them talk with a neighbor for 30 seconds about it. And then would come in after 30 seconds and say, apologies for interruptions, but let's continue. What'd you come up with? All right, now we can talk about a property in mathematics called the substitution property. We know that x and r are the same from the picture. So if you go back to the picture, ask them the question. Don't tell them that x equals r yet. Just go back to the picture and say, look at the picture. Look at the square. Is there any relationship you can see between the square and the circle, the semicircle? Are there any connections you may see between the square and the semicircle? Talk about that with your neighbor for 30 seconds. What connections do you see? Don't wait for them to talk to you. You let them talk with each other. and then they come back to you after 30 seconds. Sorry for interrupting. What did you come up with? So you maintain control. There will be a few who aren't finished talking yet. That's okay. You're not stepping on them, but you do have to consider the flow of the class. What did you come up with? Hopefully, you're asking questions that lead them to the understanding that the side length of the square is also the radius. And that's going to lead us into the substitution property, which simply says that if two measures are the same, then you can replace one with the other. That's the substitution property. So we're going to choose to replace x with r, and now we have 2r squared plus pi r squared. Go right back to the question. What did the 1,000 mean? What does 2r squared plus pi r squared mean? Well, that also means the area of the garden. Now we can talk about another mathematical concept, combining like terms. R squared and r squared are like terms. So what does it mean to add 2r squared to pi r squared? Well, the question is, what does it mean to add 2 plus pi? And we can let Python do that for us. So let Python do that for you. Say, okay, let's figure out in Python, what is 2 plus pi? And then you can introduce the concept of importing, or from math import pi. You can show them how to do that so that they can use pi in Python. And so Python's going to give you a really good answer. Still infinitely many digits, but Python's answer is pretty sharp here. 2 plus pi is 5.141592653589793. Whew. It's a good number, right? Do you want to type that in every time? Not really, no. How could we get around not typing that in every time? Will Python let us do something that's quicker than having to type that every time? Again, you need to come up with your own questions because you'll know your students. Ultimately, you're asking questions that will lead them to, well, let's make a variable. Let's just store it in a variable. How about x? We shouldn't do that. Why not? Well, that's the side length of the square. So we shouldn't use x, probably shouldn't use r. What should we use? Well, we're trying to get to a solution. We don't want to be too verbose here. It's okay. I chose A. They could choose B, whatever. Doesn't matter. So A equals 2 plus pi. Bam, we've now got A equals 2 plus pi. And that's stored into Python. Well, now we have 1,000 equals AR squared. Go right back to the question. What does 1,000 mean? Well, that's the area of the garden. So what's AR squared? Well, it's the area of the garden, right? So they mean the same thing? Yeah. Why do they mean the same thing? There's an equal sign. And they're probably not going to respond this quickly. I get that. You're learning who they are. They're learning who you are. They need to trust you that they can say incorrect things in front of you. Okay? So we've got 1,000 equals AR squared. Now you can introduce or reinforce the division property of equality. Let's divide both sides by A. And so R squared is 1,000 divided by A. And at this point, technically, they should technically know where to go from there because we had to do this in the lesson. We had to do this in the lab. R squared is 1,000 divided by A. So we're going to use the square root property, but technically that's not true, right? For those of you who are math teachers, we're not really using the full square root property because the full square root property says that R has to be plus or minus the square root, right? We're actually using the positive part of the square root property to figure out what R is. Why are we doing that? Why are we putting just the positive one and not the negative one? Well, what would it mean? Ask your students. Well, what if the radius of the circle was -2? Talk to me about that. No, don't talk to me. Talk to your neighbor about that. What would it mean for the radius of the circle to be -2 feet? Talk with your neighbor about that for 30 seconds. You're leading them into coming to the conclusion that -2 feet doesn't make sense. And so that's why we're using the positive part of the square root property. So now we've got our R value. You want to ask them questions. Do we have our X value? What do you think? Do we have our X value? Talk with your neighbor about that. 30 seconds later. Sorry for interrupting. What'd you come up with? Yeah, they're the same, right? Because X and R are the same. Well, now we can calculate the perimeter. Let's go back to the picture. What is the perimeter? Now each square has four sides, but are we going to use all four sides? Why not? Because it's the perimeter of the garden. And so the outer side here and the outer side here, that's what we want. Okay, so we want the outer side, we want 2x, right? That's the two outside parts. What about the circle? Well, it's a full circle, two semicircles, and that's going to lead you to the circumference. So perimeter, I didn't write it down here, but perimeter, the equation for perimeter, we'll use P, is 2x plus circumference, 2 pi r. And now they've got it. So again, your classroom is totally different from my classroom. Your students are totally different from my students. Does this all have to happen in one day? No. But we don't want to give our kiddos the answers. That's not going to help them. We want them thinking. We want them talking with each other. So we want to set up an atmosphere where they're talking with each other and you. But remember, you and I are guides. That's it. We're guides. We're not answer machines. We want to break away from the classroom environment that produces answers. So take a risk. Let your students talk with each other. Let your students respond. Let your students make mistakes. And you'll get questions all the time. Well, how on earth am I supposed to know that? That's an excellent question. Well, you and I know the answer to that, right? They talk with someone and they begin to make connections in their minds. Well, I learned that in math class and I'm doing that in computer class, but I see a connection here. So I've been going too long about the algebraic process. I apologize for that. But I really want, you're going to come up with whatever strategy you use. This is all a suggestion material that I'm making right now. But I would at least want to get you started in thinking about how are you going to present this in such a way that you're not giving them answers, that you're letting them think and hopefully make connections for themselves. Okay, so this is the algebraic method. Let's now actually use a second method, which actually uses a computer science technique called binary search. Those students who are really geared, created by God, to really think in computer science terms, they have just this natural skill for it, they're probably going to like this method. So okay, let's take a look at that method. So now what we're going to do is we're going to try to solve this problem another way. And the technique that we're going to use now is called a binary search method. Print, just because I can, binary search method. And what are we looking for? Well, we're looking for the solution, right? Now, hopefully at this part in the class, you've at least led them to the conclusion that the side length of the square, which we'll call x, is the same thing as the radius of the circle. Hopefully you've been helping them make connections that they're at least at that point, okay? And the second thing that we want is we know the area is 1,000. So the first thing we're going to do here is we're going to store 1,000 into capital A. Now technically in computer science we don't like to have capital letters as a variable name, but I'm going to say it's okay right now, and the reason why is because I want your students and we want our students to still make connections with their math classes, and in their geometry classes when they have area and perimeter typically they're going to use capital letters, and that's okay. So we're kind of this is give and take. We're going to remove a little bit of the strictness of the computer science principle that says variables must be lowercase. Well, we're going to say, well, we'll worry about that later. All right, so area is 1,000. And hopefully at this point you've also helped your students make the connection that the area is 2 times the side length squared of a square, 2 of those squares, plus pi r squared. So before you do this, you've at least led them up to that. Okay? All right. Well, this is how binary search method works. We're going to start by picking a number. We're going to say, okay, let's let x equal 10. And this actually is a good time to introduce the double assignment feature in Python. So I can actually say this, x equals r equals 10. So both x and r are 10. The area formula is 2 times x squared. So you could say x times x, or you could teach your students how to square something in Python and use a double asterisk. That actually will square the x plus, oh, I have to import pi, don't I? Not ready for that yet. From math import pi, and then from math import sqrt. There we go. Now we're ready. So now I'm going to say 2 times x squared plus pi times r squared. Now, question, we chose x equals 10, r equals 10. What did we get? Well, what is 514? Well, that's the area we got, right? Is that enough? That's not enough. What does that say about x and r? They're not enough. Let's try 20. X equals r equals 20. Now, here's the cool thing about idle 3.8. You can go back up and then hit enter. Grabs the whole thing. You don't have to type the whole thing out again. Hit enter again. That's too much. 20's too much. 10's too little. Some of your students might say, well, the answer has to be 15, right? Well, not necessarily, but we're going to use 15. This is the part of the binary search. We found something too small. We found something too large. Guess what we're going to do? We're going to go to the halfway point. So here's what we do now. This is what's going to help us from going completely insane. We're going to say left equals 10, and we're going to say right equals 20. And what we're going to do is we're going to let x equal r equal the average of left and right. So left plus right divided by 2. Now let's calculate the area. Too much or too little? Still too much, but better. Here's the cool thing. The binary search method says, well, if you still have too much, then don't change the left value, change the right value, because the right value is the one that's more. So what we're going to do now is we're going to say right equals r, because the current r value is too much. And now we're going to go back, grab x equals r. We're going to let that be the average of left and right. We repositioned the right value. Let's calculate the area again. Too little. Well, the right value is too little, so let's reposition the left value now. So left equals r. Go back, grab the area formula, or make the assignment, I'm sorry, and then go ahead and calculate the area. Too little. So now we're going to let left equal r again. So if the area is too little, we reposition the left value to be a little bit more, which will be the r value. Let's go back, make our reassignment. X equals r equals the average. Now let's recalculate our area. It's getting better. Too much. What do we change? The right value. I'm going to go back up here, grab right. If you want to type it in, that's fine. Let's remake our assignment. X equals r equals the average. Calculate the area. Even better. Too much though, right? Scroll up, grab the right value, make your assignment again. So now x and r are set. Calculate the area. And all I'm doing right now are key presses, right? That's not hard. Key presses. Too little? So okay, that means the left value is too small, so let's reposition the left. Let's remake our assignment. Let's grab the area formula again. Woo! It's getting better. Now we're going to be doing this for a while, but that's okay. we want them to practice with this. This is totally new. And by the way, you're not looking for mastery of the binary search process. You're not looking for mastery of the binary search process. Okay? This is introductory. You at least want them to try it. Though they won't master it, at least they've got the idea that if this number is too small and this number is too large, let's try something exactly halfway in between. And if that turns out to be too small, then what I'll do is I'll take that and the one that was above it before and take halfway between those two. And if that one's too large, then I'll take the one that was halfway at the beginning and that value, find its average, and then try that value. And so you're constantly taking half of half of half, repositioning things so that you're focusing in on the actual solution. So again, it's totally up to you what decimal place. I think it's a good idea for them to at least go to the hundredths place on this, 2 decimals, and then we'll call that good enough. So okay, the 1000 was too much, which means I'm going to readjust the right value. Okay, let's make our assignments again. Let's calculate the area. Too little, so I'm going to readjust the left value. Make our assignments again, recalculate the area. Too much, so I'm going to see, this is just button presses. This is not hard. All right, too much, so I'm going to reassign the right value. I'm going to reassign X and R, get the area value. Too much, but wow, that's looking good. Right equals R, reassign X and R. There's the area value. This is looking beautiful. Reassign X and R, grab the area. Ooh, okay, so I'm almost there. I want to get one more decimal place of precision here. So let's see if I can at least get that. Oh, too little. So I'm going to readjust the left value now. Make the assignment. Oh, almost. Right equals R, X equals R. Ha! I've got 2 decimal places. See what we just did? We're using Python as our problem-solving tool. Yeah, I could do this, but that doesn't help me work with Python. It doesn't help me learn the interaction of the editor, of the shell, which is what we want our students to do, right? And so now let's go ahead and print out R. There's our R value, a good approximate, right? R equals 3.94. So 3.50607. So okay, now let's make the connections for the perimeter again. This is where you go back and you try to help your student look at the picture again and say, what is the perimeter, right? Well, it's 2 times x plus the circumference. So we're going to say P equals 2 times x plus 2 times pi times r. And then we're going to print that P value. The perimeter of the garden is 115.52 feet. Totally non-algebraic. That is a technical that is a computer science concept, the binary search method. A lot of key presses, but that's not hard. I mean, if you're getting tired doing that, you probably need to get out more, right? Do some gardening, right? I love gardening. I hope this was helpful. God bless you, wherever you are today.